JAX is a powerful tool for scientific programming in the Python ecosystem. It provides tools to easily program on CPUs, GPUs, and TPUs with convenient just-in-time compilation, batching, and automatic differentiation. Since its launch more than 5 years ago, JAX has grown dramatically, both as a piece of software and in terms of users. It has become especially popular with the machine learning community. Personally, I am a massive fan of JAX for machine learning and general scientific computing for a variety of reasons. I won't go into these now, but I'm happy to discuss them more in a future video. I will note that JAX code videos are coming in the near future, so I hope you like JAX too. Rather, what I want to talk about today is the state of the JAX software ecosystem as we enter 2025. Although the ecosystem is broad and contains a number of impressive, useful, and powerful packages, there are still a number of hurdles to be overcome in the coming years. Just as an aside, you can see much of this ecosystem highlighted on my Awesome JAX page, in which I revived some abandoned lists to consolidate an overview of the packages in the ecosystem. Naturally, at the core of this ecosystem is JAX itself. As of this video's recording, JAX 0.5.0 is the latest release. Although the burden of Google's perpetual killing of projects, commonly resulting in abandonware, rests heavy on the shoulder of all Google's software, JAX development has been pretty consistent for half a decade. However, the support for development does not include JAX-based packages that Google also develops. In general, development prioritizes GPU and TPU support for JAX, often leaving CPU by the wayside, which is probably one of the most substantial downsides for many scientific programmers. Now let's talk about the core packages. In general, the quote-unquote core packages I consider to be those directly linked on the homepage of the JAX documentation. Broadly, these can be categorized into two bins, Google-based and Equinox-based. I want to emphasize too that many of the points that we're discussing are not unique to JAX, but represent fundamental challenges to maintaining a software ecosystem across the big tech, startup, and open source world. Let's talk about the Google-based first. These include packages such as Flax, Optax, Chex, Distract, JAXMD, etc. These repos provide a set of essential backbones. Optax is basically the only popular gradient-based optimization package, which is essential for machine learning, and many of these other packages monopolize specific niches, although there are a number of recent developments that iterate and improve upon some of these core ideas. I myself started Distrex to improve upon Distrax. These packages are helpful, and since they are used by Google, they generally receive support. However, the internal usage is a double-edged sword. Because the primary users are internal, external users can sometimes face uphill battles in receiving attention in issues or PRs. Take Distrax, for example. Of the 10 most recent issues, which span multiple months, 8 of them remain open, 2 are closed, and only a single one of all 10 has a single response from a Distrax developer. Next is the Equinox branch of the ecosystem. These packages are based on Equinox, which is both a neural network package and provides a number of utilities for working with PyTrees. These include packages such as Diffrax, Liniax, Optimistics, Quax, FlowJax, FlowMC, etc. These packages are somewhat the inverse of the Google branch. They are popular in the open source community, but lack company support and are often maintained by a single or just a few people. This potentially makes the packages prone to the Julia phenomenon, in which packages get developed by one super passionate PhD student, then discarded when they graduate and get a job. I call this the Julia phenomenon just because it's happened multiple times in a couple notable Julia packages. And in general, software with single points of failure is a priori not a sustainable methodology, but of course this is not at all uncommon in open source software. Hopefully we can learn from the broader open source community to strengthen and help promote non-corporate sponsored packages for long-term development. Now I would like to highlight 2 areas in which I think the JAX ecosystem has really augmented. The first is reinforcement learning. The advent of JAX popularity perfectly aligned with the increasing popularity of vectorized environments in RL. Traditional RL used approaches such as OpenAI gem environments that were extremely slow and did not utilize the full processing power of modern computational devices. Software such as InfPool was starting to change that. JAX provided a perfect next step in this trajectory by programming environments in JAX as well as neural networks. Massively parallel systems could be trained end-to-end on GPUs. This has led to a number of interesting results. And such environmental packages include things like PGX, Jumanji, Gymnax, Brax, CraftX, etc. In my mind, this is one of the coolest and most interesting machine learning applications, as it really takes advantage of some of the unique selling points of the JAX ecosystem. JAX has also made big waves in the LLM NLP circles. Many major LLMs were developed using JAX, and it's definitely disrupt PyTorch in this area. There are a variety of reasons for this. One of the most notable is the relative ease of distributed training. JAX makes things such as multi-device data parallelism trivial, and not just trivial in the way that you might have to install another package and use their magic commands that are opaque but only work in very niche use cases, but actually integrated into the design philosophy of the DSL. This has also grown recently as they move away from PMAP functionality to a more sharded array focus. The integration of multi-host methods is also surprisingly straightforward, working better with HPC managers like Slurm than most things tend to do out of the box. Support with sharded arrays also allows for flexible tensor parallelism, and NLP is also an area in which non-corporate open source has begun to shine. One of the most notable LLM packages in JAX is Levanter, and this is a package for training reproducible, legible foundation models in JAX, and is developed by the Stanford Center for Research on Foundation Models. In general, the ecosystem is both large and small. There's a lot of packages, but also a fair amount of churn or packages that get abandoned. Even Google's packages, as I mentioned, do not necessarily receive sustained support. For example, with the DeepMind Google merger that seemed to have killed off Haiku, one of the more popular neural network packages. JAX packages in general require a fair amount of work to maintain because JAX is constantly pushing changes and improvements that are both API breaking and of practical influence. For example, CPU JAX users have to pay careful attention to the speed of operations with every change. This is, of course, natural for pre-1.0 software, and in the long run will result in a much better JAX experience, but has implications for maintainers in the near term. Although there are a lot of packages for different areas, such as unique RL environments, when it comes to the core packages, there aren't necessarily a ton of choices. For example, if you want to do neural networks, you basically have Flax or Equinox, and Flax is by far more common for larger scale industrial machine learning workflows, although I personally much prefer Equinox. Things like Haiku, Objects, and even Trax, all of which incidentally were maintained by Google, have largely fallen by the wayside. Once you program your neural network and you want to optimize it using common neural network optimizers, Optax is basically your only choice, and so on. Now all of this begs the question, how many neural network or optimization packages do we really need? There is some benefit actually to having standardization on things such like Optax, which is now compatible with every other package because it's the only thing that people use. But each of these libraries makes foundational design decisions that are not universally good for every use case. Finally, for all the details on these packages and many more, I refer you to my fork of the awesome JAX list. Feel free to use those packages or put up a PR adding your own package. And that's all for today.